Okay, good afternoon. Today's topic is Werner's theory of coordination compounds. It is a chapter number 3rd and 2nd of the coordination chemistry. Okay, so in last lecture we already saw the introduction of coordination chemistry. In that we saw the different terms which is used in coordination chemistry, and as well as there is a IPC nomenclature of different coordination complexes. We saw the rules, applying the rules, and we get the nomenclature of number of examples, number of compounds. Today we are going to start the beginning of coordination compounds, coordination chemistry. In first lecture we just know about what is the coordination compounds, which terms are used, how giving the name to the coordination complexes. So it is just overall introduction about the coordination chemistry. But actually coordination chemistry start from this chapter. It is just beginning, means how coordination chemistry is introduced. So Werner is the name of the scientist, and he was introduced the coordination chemistry, and that's why he was called, or he is the father of coordination chemistry. And at the age of 26 he was introduced the coordination chemistry and won the Nobel Prize in 1911 for this work. So he is awarded by the Nobel Prize in 1911, but in 1893 first time he was introduced the different concept of inorganic compounds. He tried to work on different reactions. The reactions, first of all, he's trying to reactions with the metal halides with the different type of ligands, different type of solutions. So he saw the different complexes are formed, but there, and he check out the properties, and some compound shows different properties. I already told you there are the difference between the complex compound and double salt compound. So some compounds when react together, that time they shows the double salt property, means in a solid state and in a liquid state they shows the positive test of individual constituents. But some of the compounds which fail to show the all the test of individual atom in a solution state. That time he try, there is a composition, because there is an empirical formula, but complexes or compound shows different kind of test. So that time he suggests there are the compounds are different, coordination compounds are different as compared to normal salt compounds. So that time coordination chemistry was introduced. Okay, so when once he know about the coordination compounds, that time he suggests some observations about the coordination compounds, and these are the postulates, these are the assumptions he was introduced, and that assumptions help us to understand coordination compounds and their structure and geometry. Basically, once we know the structure, once we know the molecular formula of coordination compounds, after that our next aim is to predict their structure and predict their geometry. So Werner's theory helps us to know what is the possible structure of given coordination compound. Okay, so before that we are going to start some assumptions. So it is a just introductory part. So another part is assumptions of or postulates. Okay, so what are the assumptions and postulates of Werner's theory? Okay, so he suggests the first assumption is every coordination compound has two types of valencies. Means two types of valency. Valency means what? It is the number to how many number of attachment with the central part. Because in coordination compounds there are two types of constituents. One is metal, another is ligand. So if metal is there, some ligands are present, some ligands are directly attached. Ligand may be neutral, positive, or it is a negative. So in complex, it is possible there are three kinds of ligands. They are attached directly to the central part. But we already know the structures of coordination compounds. Some anions or cations which are present, basically anions. Cation is positively charged, so it is a look like or behave as a metal, same as a metal because both are deficient. But the anions which are present outside the complex, they also try to attach with the metal. But the question is, they are directly attached or indirectly attached? Okay, so considering this thing, Werner suggests the first assumption is there are two valencies of in a coordination complexes. Means every compound has two valencies. This is the first assumption he is predicted. In that, the second, there are two valencies. He said the primary valency is there. Primary valency means he suggests the coordination, some coordination compounds, not every coordination compound, some coordination compound has primary valency. The valency also called as ionizable valency. Ionizable valency means which are directed along or directed toward the central atom or ion, but it is ionizable. And when it is ionizable, it is represented as in a structure with the dotted line. With the dotted line. It is ionizable. Means when we ionize the compound in the form of cation and anion, it is ionizable. That means if the anions which are present outside of the complex, suppose X anions are there, so these are the ionizable because we get the cation part and the anion part. So this anion will be react with another reagent to form their precipitate. We will see in the next part. Okay, so these are the ionizable because these are easily react with other. So it is a primary valency. Okay, it is ionizable valency. It represented as a dotted line in a structure. So it is a second assumption. He said third assumption is every coordination compound has secondary valency. Secondary valency. So secondary valency means what? This is the number, this is the valency which are directly, means the number of ligands, basically ligands, or it is the atom, ion or molecule which are directly pointed or directly attached to the central atom or ion is the secondary valency, and it is directly considered as a coordination number. It is equal to coordination number of the complex. So secondary valency means ligand which are present inside the coordination pair. It is a coordination pair. So the secondary valency placed in the inside the coordination pair, primary valency present outside the coordination pair. Okay, it is ionizable, but this is not ionizable. Means suppose we consider this example FeCN6. Okay, K4 FeCN6. It is one of the example. So it ionizes as a K plus, 4K plus, and this one FeCN6, 4 minus, it is ionization. So this is the secondary valency. Further their ionization means Fe and Cn separate out, ionize is not possible. So there is non-ionizable. So it is equal to coordination number or also called as non-ionizable valency. Non-ionizable, it is directly relate the coordination number. The primary valency is just ionizable. It directly relate the oxidation number. Oxidation number. So oxidation number is balanced by this valency. It represented as a dotted line, but it represented as a wedge line. It represented as a wedge line or solid line. These are the assumptions. Primary valency is non-directional. Means primary valency means ionizable valency attached to the central atom at anywhere. There is non-directional, no specific direction required for the ionizable valency because it is ionizable. It is not permanently attached, it is just temporarily attached by the dotted lines. But here, in case of secondary valency, it is non-ionizable. It shows relate the coordination number of the central atom. That means it directly attached to the central atom or ion, and it is oriented in a specific direction in a space. That means if there are 4 ligands are attached, the 4 ligands are not randomly attached to the central atom. The ligands attached specifically in a particular direction in a space to the central part that will make the geometry. There is a geometry because every coordination complex has geometry. So geometry depends on number of secondary valencies, how many ligands are directly attached and how they orient in a space. So Werner's introduced the phenomena is stereochemistry. We will discuss in later part. So stereochemistry also exhibit in the coordination complexes same as organic chemistry because you already familiar with stereochemistry of organic compounds, same as here is a stereochemistry of inorganic complexes. So these are the assumptions. So in summary, keep in mind, very important, coordination complexes may have the 2 types of valency, not compulsory, but may have the 2 types of valency because only some compounds has ionizable primary valency, but every compound has secondary valency. There are primary valency and secondary valency. Primary is ionizable. It relates the oxidation number of the compound. It represented as a dotted line. It is non-directional because it is attached from any side of the plane to the central atom. But secondary valency is the permanent. It relates the coordination number. It is non-ionizable and represented as a wedge line, and it is the directional because it directed in a space to the particular angle, through the particular angle. So ligands are attached there and that makes the geometry, and they shows the stereochemistry in the complexes depending on nature of ligand. So this is all about the assumptions and postulates of Werner's theory of coordination compounds. We move to the next, Werner's formulation of coordination compounds. Formulation means how coordination compounds are formed. If they form, how we identify their structures. Once there is a particular reaction is happen, that time, okay, there is a formation of compound. So that type of compound, we check out, there are 2 ways, physical method and chemical method to analyze the product. Okay, so physical method means we can use different types of spectroscopic methods to elucidation of the structure. But chemical method used to find out there is the reactivity, means what happened there, because empirical formula we know, but which part of the compound is react with other, that will prove how the structure is possible. So chemical method and physical method used to determination or to elucidation of the structure of the inorganic compounds, same thing as in organic chemistry also. So here we are going to discuss the formulation of coordination complexes. Okay, formulation of coordination compounds. Okay, so Werner's first of all tried the reaction between cobalt chloride plus NH3. Means just dissolve the cobalt chloride in water and add NH3 is there. So he get the different types of composition. Means there are 3 Cls are removed by, so using the empirical formula, it is possible to get the different kind of series of compounds which is listed in your notes or listed in books. So which type of series is given? So first of all, he see there is a NH36 Cl3. Secondly, observe CO NH35 Cl3. Then CO NH34 Cl3, CO NH3 thrice Cl3 means how many ligands, NH3 ligands will attach to the cobalt. It is the possible, there are 4 complexes. 6 ligands, 5 ligands, 4 ligands, 3 ligands. There is no 2 ligands because coordination number of cobalt is 6. So maximum 3 plus 3 is 6. So these are the series of complexes are formed. But what is the structure? Which is the possible structure of given complexes? So how we find the structure of given complexes? हे जे कॉम्प्लेक्सेस तयार झालेत हे 4 कॉम्प्लेक्सेस तयार झालेत ह्या रिएक्शनमध्ये ज्या कोबाल्ट क्लोराइड रिएक्ट विथ NH3 molecule, NH3 solution, ammonia solution. So to predict the structure of given 4 compounds, how they predict it? So for that, very important thing is, first of all, this here is a halide. So halides are present in empirical formula, and you know if any halide compound is given, you know the silver test, silver nitrate test, okay? Because silver nitrate test is used to find out the presence of chloride in inorganic qualitative analysis. Suppose we react this solution with silver nitrate, okay? When it react with silver nitrate, he saw there are 3 molecules, 3 precipitations are formed. That means here he get the thrice AgCl, precipitation of 3 AgCl molecules. When react with this one, same solution of silver nitrate, the observation is here is a 2 AgCl, 2 precipitations are formed. In third case, again they react with, here just single AgCl precipitation is happen, but in case of their last one, no PPT. That means using this observation, he conclude in first complex there are 3 Cls which are ionizable and they form the bond with silver and form thrice AgCl molecules. In second case only 2 Cls are ionizable. In third case only 1 Cl is ionizable. In last case there is no Cl is ionizable. Means here in first case, okay, there is no any differentiate because all Cls are precipitated. But here there are 3 Cl, but why only 2 Cls are precipitated? Where is the remaining 1? In third case only 1 Cl is precipitated out. What happened about the remaining 2? And here Cl is present, 3 chlorides are present, but there is no Cl is react with Ag silver nitrate. That means no precipitation. So why this happen? That means here all Cls are ionizable, means he conclude the complexes has 2 types of valencies, primary and secondary, or ionizable or non-ionizable. Okay, so primary said that means it react first as compared to second one, that's why I called primary and secondary valency. But here there are 3 Cls, that means every compound has 2 types of valencies, ionizable and non-ionizable. Only ionizable valencies will react with silver nitrate and form the AgCl precipitation. But the other which are not getting the precipitation, that means these are the non-ionizable valencies. So using these observations and chemical reactions, he predict the structures of given compounds. So we are going to discuss it, how to predict the structure. We consider first example. In first example, all the 3 Cls are non-ionizable, means in a structure all 6 NH3 are ionizable, that means 6 NH3s are present. Here only 2 ionizable, that means only 5 NH3s are present, because the NH3 is not easily predicted by naked eyes. So the conclusion, why 5 here, why 4 here, why 3 here? Because how many Cls are ionizable? Because in given compound, the compound shows coordination number 6, because it is the tetrahedral geometry using the physical parameter, physical techniques. So that's why he conclude if there are 3 are ionizable, means all 6 NH3 present in a coordination pair. But here only 2, that means only 5 NH3 present, with that 1 Cl is there. Only 4 NH3 is present, with that there are 2s are present. So using this observation, he try to predict the structures and geometries of the compounds. So we try first. The first observation says all three Cls are ionizable, means the secondary valency is completed by or satisfied by all the NH3 molecules. So here okay, so that means all NH3s are attached to directly to the cobalt, because all are attached through the secondary valency. It is directly oriented, and we can predict this is a tetrahedral geometry. It is later part in a stereochemistry. What about the 3Cl? So 3Cl we can direct it here by the dotted lines. That means this is a structure. Means the secondary valency which is pointed directly attached to the cobalt, but the primary valency is attached to the dotted line. That means it is the primary valency, here is the secondary valency, and this is the structure. Okay. For second case, what happened? There is a one of the Cl is only 5NH3, so we just changes here, make a changes here. So here is the NH3 Cl. So I just replace one of the NH3 by the Cl. So 5NH3, 1 Cl, 2 Cls are ionizable, and 5 NH3 and 1 Cl is non-ionizable. But we can predict this one, this as a this means it is a solid line as well. It means this Cl behave as a dual role. But it is not non-ionizable. It is non-ionizable, but it is behave as a dual role, because in formula there are 3 Cls. You can write, mention dotted line or not, but actually there are only 2 ionizable. In case of third, only one precipitation is happen, means only one Cl is ionizable. We can see another Cl is here. So 2 Cls are non-ionizable, 1 Cl is ionizable. In last case, 1, 2, we can replace one of the, here is a Cl. So in last case, all Cls in a coordination pair, that means it is the non-ionizable. So all are non-ionizable. So you can draw the structure of each individually. I already provided to you in the notes. So using this phenomena, we can predict the structure and geometry of the Werner's theory, using Werner's theory. So in next lecture, we are going to discuss the stereochemistry of Werner's theory and other things related to the Werner's coordination compounds. So we stop here today. This is just about the introduction of Werner's theory. We already saw the assumptions and all things. So here we are going to stop.